Hello, good evening. My name is Abdulatif Gafar, and I'm a Python mentor on Zuri training, and I'll be taking you to the classes and objects class today. So let's begin. Python objects and classes. So what are classes? Classes is a very important aspect of object-oriented programming because it provides means by which we bundle related data and functionalities. So you must have been hearing what is object-oriented programming. What exactly does it entail? So it's just a programming paradigm. By paradigm, I mean it's a it's a systematic way uh, which is adapted in programming to deal with classification of data and functionalities. So it's more of like a translation of real life scenarios into programming language. So yeah, and it's centered on the concept of objects. So the object concept, what is the object concept? We're going to have to use an example to describe this. So for example, and like I mentioned, it's just for translating real world scenarios into programming so that it's easier to classify different data and the functionalities related to that data. So let's take an example of the car. So a car is an object in real life. It's it's you can use it for so many things. That's as regards to the functionality, and also have different properties. So and we also have different types of cars. So the different type of cars will fall under different properties of those cars, and also all the properties related to color, like the transmission type, model. For example, looking at this, we have the Audi model, the Nissan model, and Volvo. These are all parts uh, of classes of the car class. So if you're going to translate this in programming, it's easier for you to group them into different objects. It's easier for you to group them that way into one class, putting up all the objects into one class. So I'm going to show you the programming aspect of it. It's just for you to get a clear idea of what a class really looks like. You show that it doesn't look so weird because it's just it's just like a blueprint. Let's say it's a blueprint by which we categorize objects. What the objects are those things that are related to that class. So you can see the example here is we can say the car class. We call the class a car. So the objects, an example of an object, we take the Audi model, or we say the Mercedes-Benz model is an object of that class. So, like I mentioned earlier, it's a method of categorizing the data that have similar properties and functionalities, just to make it easier to code or easier to program, easier to manage the data. Because basically, what you're doing when you're writing an automation script or you're trying to program something, you're basically dealing with data, manipulating that data to bring out something, to bring out an information, to carry out an action. So classes really helps with that. Rather than writing multiple lines of code, you're able to categorize things that are similar into under one umbrella. And that umbrella is what we categorize as class in object-oriented programming. And Python is a very good at is very good with that also. Similar with C and Java. We're talking about Python here. Yeah. So the method, just like methods, you're gonna see the definition of this input parameters. I'll be using them a lot. Yeah, methods, attributes. Those are the terms we use as regards to classes. The two major terms. Those are we talk about the attributes, which is related to the properties. That's what we call properties. It defines the properties of the object. And the method itself talks about the functionality that object can carry out. So if you're looking at a car, basically, the things you can see are those things you classify as the properties. You say, oh, it has a color, then that is an attribute of the car. It has a door, it has two doors, that's an attribute of that car. It has the max speed it can go is 120 miles per hour. That's an attribute of that car. So the more of the things that are more that looks more of like an action, that's what we call methods. So when you say the car can start, yes, that's the method. Starting the process itself, that's the method. That's a functionality. Acceleration, that's a functionality. And changing transmission, yeah, although you can classify other properties as okay, maybe it has a 4G or is a four-wheel drive or a two-wheel drive, that's a property. But once it involves an action, then you classify that part as a functionality, a method. And in programming, that method is what you call the function, basically. And in the previous class, I'm sure a colleague of mine took you through how to instantiate a function and how to deal with that. So another example of the object concept is just like a more practical life experience is where you have a customer class. You can create a class known as customer, and this customer itself, like you have a bakery, they have to make orders, they have to place orders, they have to cancel orders. Those are functionality related to a customer. It's just you've categorized that class itself as a customer class, and it's going to have several different properties at which you're going to use to identify that an instance of that class. When I say instance, I mean the object once what you create from a class. So an example, let's say customer A comes, the data you're going to be dealing with customer A, those are his properties. You say he has an email, he has a phone number, he has a full name. So those data, those are the properties of that customer. If you're going to describe the customer, you're going to describe the properties. So what other aspects do we look at now? We now look at the methods. Those are the functionalities a customer carried out. So a customer can place an order, a customer can cancel an order. Those are functionalities and those are methods. So I just gave two examples just to make it more understanding, more practical life example. So the basic terminologies I've used now since the beginning, I've talked about attributes, which simply refers to the properties affiliated with a given class. For example, one of the attributes of the car class is the color, and which you saw in my previous slide. Methods, these are functions affiliated with some class. Functions, we already know what functions are. There is a block of code designated to carry out a certain functional, certain work or something. Is it to do? Yeah, sorry. Yeah, it's just a block of code, but block of code majorly to carry out one action. That's what a method is. So, and my colleague has discussed that in the previous class. So an instance, I use that term a lot also. An instance of a class refers to the object created through calling of that class. So this is more of like the code example of what you do when you want to instantiate, when you want to create an object. So if you, for example, we have the car class, it has different attributes. You can specify them, the name, the color, the model. It takes in all those attributes. Then Lamborghini itself is what we call the instance of that class. It's an object created from that class. We're going to go into coding now. So I'm going to show you a more practical aspect. So in the practical, what we're going to do is we're going to create a class. We create instances of that class. We set attributes of the class, which relates to the property. We create methods in that class and call methods using instances of the class. And we also discuss a bit about docstrings in classes and its importance. So let's go into coding right now. Enough of the talk. So I'll be using PyCharm ID, and this is the first practical. So the first thing we'll be doing is we're creating a class. So to create a class is very simple. You use the Python keyword class. and you specify the name of the class. Let's keep on with cars. I like cars a lot, so let's deal with cars. So we specify cars, car as a class. Basically, what you've done, you've already this is a class, but the class is doing nothing. So if it's doing nothing, then you have to pass in the pass keyword just to ensure that you don't run into error, because you can't create a class without putting any block of code on that. That's a syntax error, and Python will flag it. Uh, so this is a class. If you try to print out the type of car, it will tell you what exactly it is. Let's try to run that. It's a class type. So basically, that's all you need to do to create a class. So we've created our first class. So the next thing we have to do, we look at how to instantiate a class, how to create an instance of a class, sorry. So to create an instance of a class, you need to specify a variable that you assign the class to. So for a car, an example of a variable we might want to assign that to is let's just deal with simple basic terms. I say car1 equals, so we create an object of the class. You just use the, sorry, excuse me. Okay, that's just pep. Good. Okay, yes. So given this, you've created an instance of a class, because now what this means is this variable has been assigned, has copied the blueprint of this car. So it's just basic. You just use the equal to sign to create an object from that class. So let's print this out. Just have a look at what this is. It will point to the memory R1. So looking at this, you see it's an object. This signifies that it's an object of that class because it's dependent on the main function of car, which is a class we're calling. So basically, that's how you instantiate a class, but that's how you create a class, and that is how you create an object of that class. So, okay, we'll comment this out, and let's move on to the next aspect. So how do we set properties and attributes of a class? So to set the attributes of a class, we use the Python reserve keyword, the uh, init method. So we use the Python, you have to define the function, and you call the init method, and you specify, okay, that's good. That's right. That's a good thing of using IDs. Just complete your code for you. So you specify self. What self signifies is the object itself. Like it signifies the object that you're taking in. So by calling the class, whenever you call a class, it takes in the object that you're assigning it to. It takes in the object and it calls the init method, which is the constructor. You can call it the constructor. If you're familiar with other languages, that's what they call it, the constructor. So this initializes the variables in the you specify under the class. And now we can now define the parameters or the attributes that we need for for the class car to have. So we can specify, okay, let's say the car class has a number, it will have a name. You can specify the car name. You can specify car color. Let's just use color. Not necessary to write too many words. Name, color. What else? Let's say the drive, whether it's a 4-wheel drive or 2-wheel drive. I think that's fine. Let's just do it too. You can list as much attributes as you want when you're testing it by yourself or when you're trying to write your own code. But to keep it short and simple, we'll go with this. So if you want to create the attributes, if you want to essentiate the attributes itself, you have to specify them using the self keyword. You can't create the object without specifying the without using the self keyword. And this is what I mean. I mentioned that the object itself, the car, is being passed into the car class, and that is what this self signifies. So let's say we're taking the car one, and we try to specify an attribute. Let's say it has a, let's say the name equals to Mercedes. Well, okay, let me get rid of this first because it's just try and error. Pass. So if you take a closer look at this, although it doesn't have the attribute specified, but you can get the attribute. You can set the attribute directly. You can set an attribute by calling the name variable. Any other property you want to create for that object, you can just put it in here, and you use the dot notation to specify it, and you assign it directly. The only issue with this is that this defeats the whole purpose of creating a class, because you have to do this every time you create an instance of that class. If you create car2, because you have to do the same thing. You have to do car underscore 2 dot name or dot color equals, let's say, Benz. So doing this is just a repetition of code, and you have to keep your code dry as possible. That don't repeat yourself. So that's the purpose of classes. It assists you in writing more concise code and making your workflow neater. So let's try to print this out so that we can get a clear understanding of what I mean. Let's print car.name. And you can also do the same thing, Command D, and print car2 name too. You can do that. So let's run this. You see, we can see the property or the attributes of that car is being printed out. So it's assigned, the name has been assigned to Mercedes, and car2 name has been assigned to Benz. So that's just the simple idea of how the attributes have been set. I've set the attributes for the object car1, and I've set the attributes name for the object car2. But like I mentioned, if you do this multiple times, it gets tiring, and you just have so many lines of code to write. And that's why we use the initialization method in the class to help us carry this out. It makes it easier. It makes your code cleaner, and that's the whole point of using classes. So I'm going to just comment this out just to ensure I don't run into errors. Okay, so as I explained earlier, you have to use the self keyword because I told you self represents the object you've created. So what happens under the background of when Python is running is that it takes in car, which is the object, as part of the argument. It takes in this car as part of the argument and passes it into this init method, which is automatically run. So the same thing you're seeing here, where you see car1.name equals Mercedes, is what's going to happen when you say self.name equals name, while the name represents whatever you pass into it. I'm going to show you soon. So just follow and you get the idea. So let's see. We want to specify now the name attribute. So you call in the self keyword, you specify name, and you equate it to name. Actually, you don't even need to specify it as name. You can call it C name, maybe car name. But note, when you call this car name, then when you're trying to work on it, on the on the attribute itself, the car name is the attribute. This is a parameter that is being passed in. So don't mix it together, but it's good in that when you're coding, just to save yourself from errors, that you specify it as the same name. Sometimes it's helpful that way, so you don't get confused. So let's just run it quickly. And okay, before that, I'm going to show you something. We need to pass in the other arguments into the car class. As you can see, the init method is specifying self, name, and color. These three attributes, these two of them are attributes, and one of them represents the actual object that is created. So once you call in the class car, you have to specify the attributes that you're going to be passing into this initialization method. So let's say car one, we want to call the name. The name it's with Mercedes. So we're getting back to Mercedes. And the color, let's say the color of the car is silver. Silver. You can specify model AMG. So we keep going on and on. If you have tons of attributes, you can put it in yours. But this is enough. So we can specify car two as let's say BMW, and the color is what color? Let's say blue. So we have object one, object car one, and object two, which is car two. So just to be to confirm what I told you earlier about the attribute itself being the name you specify with the self keyword, is not the parameter you're being passed in. Is the self key is the one that you assign to, and you use the dot notation with the self keyword. So I'm going to just run it quickly, just for you to have a look and notice that if you try to call car.name, it will throw an error, attribute error. Car object has no attribute name. That means it has no attribute name because what you specified here is car name, and name itself is just the parameter you passed in. So car name is the attribute, while the name is the parameter that you passed into the car class. So if we fix this now and print car name, what do we get? We get Mercedes. Correct. So now that's a good way. That is now working fine. We don't have any issues with that. So similarly, we can specify. So just for, I just wanted to highlight that point to you so you can get the clear understanding of which of them is the attribute and which of them is a parameter. But we can just still specify it as name just to reduce the number of lines we need to write, or reduce the time we use to spell that. It's quite small. So self dot color now. Sorry. Equals color. Sorry, excuse me. Okay, yeah, self.color equals color. So now we'll specify the color attribute. And Now we can print out we can now do the same thing for car 2. We can specify the name and we can specify the color. You can try to get the attributes out. So the car class has two attributes now. It has the name attribute and the color attribute. So the next thing we're going to do now is now we understand what the attributes mean. It just means the properties of that car, of the object that you specify. So let's go further and try to get, let's create a method for the class. Like I mentioned, a method is just a function which describes an action the object can carry out. So we specify, let's say car 1 can, we say accelerate. We specify it as accelerate. Let's say accelerate. Let's just call it accel just to save us time. So similarly, like the init method, once you call once you define any other method in the class, it has to take in the self keyword. So so that you can use, like I mentioned, it's passing the object itself, so it can deal with it can have access to the attributes related to that class. So okay, so for accel, let's just say I'm not going to, because of time, we're just going to print out, and I'll show you. So we can use this. You can print out and specify format. Let's say self.name. Now you see the reason why we have to use self, because now you have access to the object's attributes. If you try to get the attribute without specifying self, you're going to have an error again. You get to say name not defined, and you have to define name, and we don't want to do that. So self.name, we can say accelerate at 100 mph. Okay, this is wrong. Okay, yeah, that's it. So once you call in the accel now, once you call in accelerate method or function, you can easily print out, you can easily carry out the statements beneath. Like you mentioned, the function itself is just a block of code that carry out an action. So you can do so many things. You can probably you have data or property known as speed. You have property known as distance. Then you can use that idea. You can use the attributes there to calculate the acceleration. Then that acceleration itself is more like is a functionality affiliated with that car. But for sake of time, I'm just printing out the name and telling you, oh, it accelerates at 100 miles per hour. So if you want to use the method of a class, you have to call the function itself. After specifying it, remember, you have to instantiate your class. You have to create your object, number one. After creating your object, then you have to define the method that you want to call. If you don't define the method and you don't pass in the self keyword, you won't have access to the attributes related to that object. So now we have our class, we have our method, then we can simply just call the method. How do you call the method? You just specify the object dot, you use the dot notation, then you use accel, and you use your square brackets, sorry, your brackets, just basic brackets. And that's how you call in the function of that class or the method of that class. Why does it have access to it? It has access to it because, like I mentioned, the car class itself is like a blueprint. And what happens is that whenever you create an object of that car class, it just passes the blueprints onto the object itself. It's more of like living in an estate and they have a blueprint for all the bungalows available. once you get to land and you're trying to create a bungalow, which is a house under the tag house, the house class, basically the blueprint, you're going to build it the same way as others in the estate have built it. So that blueprint, you have access to the size of the house, the shape of the house, does it have a garden, or all information like that. So basically, once you create the object of that class, you have access to all the functionality in it. So, and that is how you call your um your method of a class. So we can run this. Let me comment this out so we can see clearly what's happening. Okay, spent 30 minutes already. And I'm going to run this now. So as you can see, the output here is Mercedes accelerates at 100 miles per hour. So you can do anything you want within this code block here. You can, like I mentioned, if you have length, you have distance, you can do your mathematical calculation and at the end arrive at the acceleration of that particular car. So, but now this is enough for us. And if you try to call in the other objects, you say car2 and the accel. It's also specified based on the property of car2, not car1. If you, as you can see, car1 has the property of the name is, it takes an argument, name and color, and passes this into this. And the name is Mercedes, and the color is silver. So similarly, you have car2 BMW, the name is BMW, and the color is blue. So if you want to say, oh, let's try to use the color attribute. You can do the same thing to, let's say, self the color. Let's say the blue BMW accelerates at 100 miles per hour. So you're going to have the color being specified and the name of the car now. So we run this code quickly. And now you can see the silver Mercedes accelerates at 100 miles per hour. I don't know where the silver Mercedes is a specific type, but I think you should have a clear understanding of how you're able to call methods of a class. And you can see the blue BMW accelerates at 100 miles per hour. So like I mentioned, now you have access to all the methods of that class, and that's it. Now you can create your own class, you can specify your method, and you can also initialize the attributes of that class. So we're done with that aspect. And one more thing is that when you're creating classes, it's very important to understand the relevance of docstrings. Docstrings helps you just like is a documentation. It helps with documentation. So it gives you an idea of what is going on in a particular class. Most of the most of the classes in Python itself, the built-in classes have these docstrings related to them. An example of a class is the dictionary class. If you try printing the help functionality of the dictionary class, let me comment this out so you don't get confused. Yes, if you try printing using the help keyword, and we're calling the dict class. I'm sure if you remember in the last class, if you check the type of dict, you will see that it's a class also. So try printing out the help functionality. You can try it on your own. You will see what I mean by the docstring. So we're going to try it here. And as you can see there's some explanations here that gives you information about a particular class. So when you're building your own class, remember docstrings are very important. You put them as an explanation. How to do it, I'm going to show you, and I'm going to specify it in this particle right now. So for example, you can see these are all description regarding the class dict itself. And it also has some methods. For example, remember you used the get, I think you used the length attribute. you use the pop attributes, you use keys in the last class. So these are all functionalities related to that class. So that is why you can call it whenever you instantiate a dictionary. That's why you can call all these methods. So I hope you understand what I'm trying to say, but I'm going to show you what I mean by docstring. So to write the docstring is very easy. Just uh, three quotation marks, and you can specify them in multiple lines. So everything I write in between this block of quotation will come out as a docstring and as a documentation for the class. So let's say this, we can say this is a car class. The importance of this is that you can write your code today, you understand the functionality very well, but if you don't put in documentation, you come back in, let's say, 3 weeks' time, and you'd be surprised that you look at your code and you don't understand what is going on there. So it's important to document whatever it is that you're doing. So also, if another person picks up your code, can understand by just looking at it or by using the up keyword what is going on in your class or what is going on in your code. It's not only just attributed to class alone. You can do it in every aspect of your code just to make it more readable or more understandable for someone else or for yourself later in future. So this is a car class. So we can just print out the help keyword using, now we use the car class. So let's try this. Okay, name and color. Okay, okay. Sorry, we don't need that. Sorry. Okay. Escape. Sort. We don't need to call the class. We just need to specify it. Let's see. Run. So take a look at this. If you notice, this is our car. This is our class car. It's inheriting from the built-in object. That's a super class. It's all classes you create in Python inherit from the built-in classes, built-in class. So as you can see, you can specify, you see the attributes of the car and you see docstring itself. This is a car class. That is what I wrote here. The docstring, this is a car class. So if I write more information as guys, oh, this is a car class that takes in the name and color params and specify the acceleration of any given car. So with that, that the details are complete. Then anyone that picks up my code and is confused a bit, you just know, oh, the docstring is there, and you're ready to go. You understand now what is going on in the code. So get used to writing docstrings. Yeah, you can also specify it. It's not only affiliated to writing it in the class itself. You can write it on top of the. You can write it in on for your methods also. You can say, oh, you say this is a method for my car class. So we run that. Let's stop this. Okay. So we run this again. And now, okay, let's ourselves. The docstring should appear here, right on top. I think I need to save that. And here we go. We run the code again. Okay, we can still see this is a car class, the docstring, the first one, but the other one is not showing for some reason. Okay. Let's do this again. Methods defined here. Okay. Okay. We just it should that should show up down there. I don't know what's happening, but we don't have time. So you can just test that on your own. It's going to show, I'm sure. I'm sure because I tried it before coming to this forum. Yeah. So I think that's it. I've covered majority of what I needed to cover in the practical. And we've looked at creating classes. Yes. We've created instances of our class, which is the car one and car two for the car class. We set attributes of the car, which is the name and the color. We set methods in the class, which is the ASL method that we did. We call the method, which is we use the dot notation to call the method with brackets. And yeah, we call the method using instances of the class and doc strings in classes. Yeah, and we also specified our doc string. We use our doc strings and we saw the importance itself. Like it gives us a bit documentation of of what the class entails. So let's do that again. This is a car class. So okay, so we have all of that. We've covered that. And the next thing we're going to cover in this class, this is just an additional thing. A lot of people have been complaining about having errors. And when you see errors, don't be scared. Although you, you could be scared, you could be agitated, but there's a way you look at it. There are two in Python. There are two ways to deal with errors. There are two kinds of errors that we have. So I'm going to present my screen now. So just a moment. Yes, we have the syntax error and we have exceptions in Python. Basically, syntax error refers to as the errors you get when you make an error related to syntax. Let's just put it that way. Okay, when you do something, when you write the code itself in the wrong format that is not specified in that does not match the Python blueprint of writing that particular code itself. Yeah. So for example, we have the while statement in this place, while true, print hello world. Now, if you take a closer look, the format is always comes, it specifies the file for you. That's how the error comes. Then it shows you the line of code that is being affected with an arrow sign. And it tells you the kind of error it is. So for this one is a syntax error. Why is it a syntax error? Because after a while statement, you should have your semicolon or your colon. Yeah, your colon itself. You should have your colon. So that is why it shows a syntax error. We are going to show some examples in the practical, in the second practical, and we'll have a closer look at that and the kind of error. Some errors. So an example of another syntax error is indentation error. Once you make an error of indentation, rather than using the four spaces, you used maybe two, and Python is very, 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 very concerned about its spacing and its indentations. You don't want to do that. So, but if you use an ID, you get others sorted for you easily. But that's an example of another syntax error. Yeah. So, and the other kind of error we have are the exceptions. These are inbuilt Python error. It takes note of your this a good difference between these two is in terms of syntax error, when you try to run your code, it doesn't occur before it occurs before you run your code. Your code doesn't run if there's a syntax error in your code. So once you have an error and your code hasn't even executed, you should know that it's a syntax error. But if you have exceptions and your code started to run, or maybe at some point got terminated, then you know you have to deal with exceptions. And this is something related to maybe how you specify your variables, or which is maybe a name error, maybe you're trying to access a variable that you have not defined, or you try to divide with a zero, which is a zero division error, or a type error. You try to work a string format with an integer operator, uh, that is going to give you a type error. So it's very important to know all these type of error. For example, look at it here. This is an example of zero division error. You try to divide an integer by zero, or you try to divide any number by zero. You're going to get a zero division error. You specify the file, you specify the line for you. So whenever you see an error, you go to it, you look closer and you look at the line. It's also specified the module it is. Modules are just uh, Python file is a module. A Python file is a module, and you can import it from another location in your file path. So once you look at it, you look at it carefully, you look at the line where the error is occurring, you look at the module it is occurring in. And you can, if you're using an IDE like PyCharm, you can click on it, it takes you directly to where the error, where it assumes the error lies. Then you start debugging from there. And my colleague has showed you how to use the debugging tool in his previous video. You use your breakpoints and you also use a debugger. And that helps a lot when you're trying to find out what exactly is wrong with your code. So the another kind of error is you have the name error. The name error, which has to do with um, trying trying to use an operator on a kind of variable that is not applicable to. For example, what is happening here is that you're trying to add an integer to a string. You can't do that. You can add an integer to a string. Or they can use some operations like multiply, where it's increases the numbers of that particular string. But you have to be very careful when you're trying to. Oh, sorry, that is type error. That is type error. Yeah, for the spam aspect, is name not defined. Name not defined. That means it's a name error. That means you didn't specify spam before you started writing. That means you didn't specify the variable spam before you started calling it. And I think we saw an error like that when we're doing the first practical. And we have the last one is the type error, which involves trying to carry out some operations in two different types of objects, the int and maybe an integer and a string object, which have different properties, and you can't carry out those kind of operations on. So let's have a short practical on this. And there are ways of handling these errors. You can use the try except block, try except else, and also the finally block of code. It's just a better way of handling your errors. When you can categorize them, you know what you're dealing with, then you can actually trace where your error lies. So also you can, we are going to have a short practical on identifying the syntax error, which I've shown you here. You see the Python Python will signify for you what kind of error it is. It's either it's a built-in error, it's a syntax error. It can't be more than that. And you can also raise your own errors. You can raise your own errors. You can say, oh, yeah, at this so point in time, if you write a block of code, you want to raise an error. Maybe you want to raise a zero division error for your own code, just to make sure you stop the execution, to prevent maybe a break of code along the line, or to just carry out maybe another operation. So what you use majorly in handling errors is you use the try except else block, and the finally block also when you're dealing with um, operations that you have to still run the code at the end. Finally, the finally block, what it does is that at the end of each and every one of your code, all the blocks of your code has run is going to run. So irrespective of what happened, irrespective of the error that is in the system, it has to run. And you use this maybe when you're trying to deal with file opening. Maybe you're trying to open a file, and along the line, some files have opened, but there was a file not found error. Then um, then you still need to close up all the previous files that have opened. Then you have to use the final block, because you can't leave that in memory. It's going to just be a dump in your system. So you close all that, used for like subscription closure and things like that. So we're just going to go into the second practical now itself, and we'll try to look at how we can um, write a try except block. So basically, let's just look at an example of an error. Let's use the while error that we saw in our in on the slide just now. So while true, what happened is a user printed his outputs. Let's say printed, yeah, Zuri is now live. Okay, which it is. So as you can see, if you're using an ID, it marks it for you that it's expected, but it's a syntax error. But we'll try to run it and see whether our code will even run. Syntax error. This error occurred just before the execution. So as you can see, it tells us what kind of error it is, the position it assumes where the error is occurring, and also the file path. As you can see, if I try to click on this, it takes me exactly to the file path. So if you're dealing with imports and the error, or you're dealing with other modules and the error occurs in that module, like I mentioned, module is just a file in Python, and you specify other files like with the import key. You can drag in other files into your own work file with the import keyword. So it specifies the kind of error it is, a syntax error. So once you see a syntax error, you already know it just has to do with the way you're writing the code in Python. Python has a way it writes its own code. You shouldn't write it any other way, or else it flags it as a syntax error. So the syntax says that it's missing a column, and print that out. So if you try to print out like this also, I think you should have this indentation error. Okay, indentation error. This should be erased error then. And you have another error, it's known as indentation error. And it specifies also the line. It says line 2. If you look at it carefully, line 2, that's where the error is. And the file also where the error occurred. So once you see all these errors, don't be scared. Take your time, look at the kind of error it is. If you haven't seen the name of that type of error, like for example, this indentation error, you know it has to deal with maybe spacing. Then you have to look through your code. Where do you look at? You look directly at the line is specifying, line 2 is the one blank. So, and you get to that. And from there, we can fix this. 1, 2, 3, 4. I will try to run that now. Yeah, and I've plunged into an infinite loop. So once you're using a while loop, always remember to break or to specify a condition to make sure you don't run into an infinite loop. Let me stop that. Okay, keyboard interrupt is also a kind of error. It's a built-in error though. You raise it. So, but that's part of Python's key exceptions. It has it inbuilt. So we use the break keyword so that it just breaks immediately, it runs the code. So we can run this. And we now see Zuri is now live. So be careful when you use while blocks. Make sure you specify a condition to break out of the loop. Yes, or else you plunge into an infinite loop. So that's it about syntax error. So we're going to go straight into the other kinds of error, the exceptions, and we'll use try block for that. So, okay, let's use to specify a try block is very simple. You just use the try. Make sure you remember to use your column, and you specify your code, your block of code. Let's say you do something. I'm using the okay. Then what you do is you specify an except block. And you specify when you use an except block, if you use it generically like this, then what it means is that it's going to catch any error in the system and it's going to print it out. It's going to work on it. Whatever you specify under this code, it will do. So if we do pass, that means we don't want it to do anything. It's just going to look at the error and it's not going to flag it. So an important aspect of when you're trying to use the try except block is that you should be careful. You have to know the kind of error you're trying to catch. And when you're trying to catch a more generic one, so that you don't go into a mess when you're trying to debug your code, it's better you specify the kind of error it is. I've mentioned the type of error there is. You've seen we have we have the name error, we have the zero division error, we have the type error, and these are all kinds of errors that you can expect. It's more like you're expecting an error. You're trying a code and you're expecting something should go wrong. If something should go wrong, then you should have what's called a block of code to cater for that. So let's write a function here. Let's just write a function. You should start getting used to writing those kind of things. And say it's a calculated calc. Let's say function calc. What it does is that it takes in two parameters. Takes in num1, and let's say num2, number two. And what we do in this is that we should I take in, okay, let's just make it more interesting. Yeah, it takes in num1 and num2. And what it returns is that it's very simple. It just returns the addition of num1 plus num2, num1 plus num2. That's it. Oh, no, let's say num1 divided by num2. This is what it returns, because I know the reason why I specified this. So it's just to make us see the errors in the code. So now let's specify num1. We can say it's what was insert? Yes, we specify our first number. We can say num1 equals. We'll specify it as an integer. Takes in an input, and I say enter number. Enter your first number. Okay, I'm going to put this in the try block, just to make sure that we are catching the errors that are going to occur, because we're going to induce an error in this code. So we have num2. We specify num2. Not necessarily it has to match the name, but we can just specify it like that. Then we specify it as an integer and put the input, enter second number. So now what do we want to do? What we want to do is very simple. We call in the calc method. We call calc, and we specify addition. We can specify a variable to take in the value. Addition equals to calc. We call the calc method, and we pass in num1 and num2. Simple. So we're passing the arguments num1 and num2, which is going to go directly into this. Okay, showing me. Okay, it doesn't matter. Yeah. So it takes in num1 and num2, and it carries out the additional. It calls in the method calc and does the division. Oh, okay. I said addition. Let's just make call this division. It's called a division, so it makes more sense here. Yeah. So it takes in the argument num1 and num2 and pass it into this method parameter, and it returns num1 divided by num2. It returns the division of both numbers. So we're going to run this code. We're going to use an except zero division error, because I'm going to induce a zero division error, and I'm going to make it pass, because I don't want to carry out anything on the error. So you see what I mean when you specify pass, what happens? So we run this block of code, and we are number one. We're asked to, okay, passing our first number, it should be like this, so it makes it clearer. So we run this, stop and rerun. Okay, yeah, enter our first number. So we can enter our first number as let's say 2, because num1 is what we want to do. Is what we want to be the higher value, and we want the other one to be 0, because we want to induce a zero division error. You can't divide a number by 0. So once we do that, what happens? No error shows, because we have capture the zero division error with the except block. And what we did under the zero division error is that we passed. We didn't carry out any functionality. So if you go into your code and you write, oh, you want to print out, you can't divide a number. Oh, no, sorry about that. I need to write this in. Okay. Can divide a number by 0. So basically telling the user that you can't divide the number by 0. This is the error you want to return. This is the error you want to return. And now we don't need the word pass. And if you want to return more detailed error, then you can specify here. So if we run this code, what happened is that, okay, we run to 0. And what happened? You can't divide a number by 0. Now, the reason why this is easier for us is because we know exactly the kind of error we're going to get in the system. If it's a zero division error, then you can specify it. So if you want a more detailed error, you can say 0 as error, as error. You can specify the kind of the detail regarding the error as error, and you can print that out instead. You can print that out. Let's say you print out error, and we run the code. What happened? Okay, 2, 0, division by 0. That's the error itself. Then you can just make it more clearer by saying error, division by 0. So run the code first and specify 2, then 0, then error, division by 0. So now you've made it a bit more concise. So if you want to capture any form of error, then you can not specify. You don't need to specify anything. You can just use the except block. And what you do is you can now run a particular code you want here. Maybe you can just say print error, and that's it. So any error that occurs in the system, it just says error, even if it's a zero, even if it's a, let's try to do something. We're trying to divide a number by a string. So we're going to do this 2. We're now specify W or divide it by 0. Can you divide 2 by 0? Error. It still specify error. So if you're writing your code, you need to be careful. Now you don't know what kind of error it is, and you'll be rambling all around. So it's better when you're specifying your except block, you specify the kind of error you want to capture in it. If you're not specifying the kind of error you want to capture in it, then you should be sure that the errors that is going to be coming through this particular block of code does not go beyond some particular types. Maybe it doesn't go beyond exist error. So I'm sorry. Doesn't go beyond what's it called? The type error. For example, now as you specify 0 here, the error that flags out is not the division error, it's the num error, because now we're specifying as an integer. And it only takes in integer output, integer input. So once you specify any other kind of input in it, it's going to flag. Let's see. Just to be sure, we write in type error. Yeah, type error. That should be the error. Then we now say print out type error. So we run the code. Let's say 2, say 0. Oh, it's value error, sorry. It's value error. It's value error, not type error. So invalid literal for int with base 10, 0. So it's a value error. So this is the importance of capturing errors. So now the reason why it doesn't capture this value error is because I specified exactly the type of error I wanted to capture, the type error, which it is. So if it's come across any other type of error, it stops. The code breaks. It stops working, and it moves to it prints out the error, and it doesn't go to the next line of code. So we have the else, which you can use to just specify any other thing that if it doesn't see this kind of error, then if it doesn't see the except block error, then you can just come into the else statement and print out the no type error, no type error. For example, just say no type error. Then we try to run this. Then we specify our first number as 2. And now we won't specify it correctly and we say 3. What happened? It says no type error. But we're calling this, okay, we're returning this. Let's print out division. Let's print this out just to make sure you see that the code is working correctly. So we run this again. So we print out 2, print out 1, 2 divided by 1, 2.0. So it's returning it as a float. So it's saying no type error. So what happens is that the else block fires if the except doesn't catch any error. So you just specify what next it does after. So after running the try block of code, it doesn't see any error. It goes straight into the else block. So, and the last one we have is the finally. Finally, with like the name implies, it's the final block of code. It runs irrespective of if there's an error or not. So we're going to print out this. We're going to print out this would print out irrespective of error. It's just too long. So we're going to run this code again, and we're trying to induce another error. Okay, let's first get rid of, okay, let's just do that. 2, 0. This is a 0 division error. We know our except block won't catch it. Our else block will catch, and the finally block will catch, would execute. Oh, okay. Yes, so as you can see, we specify the first number, the second number. This will print out irrespective of the error, and that's what our final block is doing. It prints out irrespective of the error. The else aspect doesn't fire because after there is a break in the code, after the code breaks, as in after there's an error induced in the code, nothing happens again. The code doesn't work anymore, except the final block fires. That's the only thing that fires, and that's the importance of specifying a final block, especially, for example, when you're dealing with, like I mentioned, subscriptions that you have to close or files that you have opened. And maybe within those files, there's just a bug and maybe one of the files is not in the specified path and there's an error thrown. So just to make sure that you don't have a lot of files open or dump files, you have to make sure you specify in the final block what happens to those files. So that it's a good example of where you use the final block. You can just close up all the old files irrespective of if the code works or not. So the final block is like the finishing touch. It closes everything. It does the last set of code irrespective of error in the system or not. So I think that's the major thing. That's the major thing. I think I've used more than my specified time, but I hope you understand the whole concept itself of using the try except or else block, and also the concept of classes that we have covered in this short class. So I hope it's been a useful class for you, and that comes to the end of my of my of my class. Thank you. So if you have any question, I don't know whether I still have time to answer them, but feel free to post it on the Slack channel also. And we have tons of mentors there to help you out and help you sort that, help you find solutions to your problem. So I'm going to stop sharing for now. I'm going to and